Hey, Julia.
Hello.
All right, things are working. Thanks for being patient with me today. We'll get the full time in for sure. If you're seeing my screen, you should see x squared minus 16 equals 6x.
Yes.
Great. This question, there's a couple of different ways you can solve it. You'd probably say solve. And let's just review some of those options. You could factor, maybe. Okay. You could use the quadratic formula. You could complete the square, which is actually what the original instructions said, but we're not going to do that. And then the last one, you could graph it. Do you know if you get a graphing calculator on this or not?
I'm not sure.
Not sure. So that would be something to find out. For now, let's do the following. Let's factor it. So to do that, you want to bring the 6x to the left side of the equation. And you recall that you get x squared minus 6x minus 16 equals 0. So when you factor, you're trying to find two numbers that multiply to negative 16 but add up to negative 6. If you know those numbers, go ahead and tell them to me.
So add up to 6 and multiply to 16?
Negative 16. Negative 16.
Negative 16.
Yeah. So see how these all add up to, or multiply to negative 16, negative 1 times 16, negative 2 and 8.
Yeah.
But they don't, when you add them, like the first two add up to positive 15, these add up to positive 6. We really want negative 6. So you change the sign on those. 2 and negative 8 also
Oh,
works.
okay.
Okay. So it would be x plus 2, x minus 8 equals 0. Okay, so from here, you set each of these equal to 0. You set x plus 2 equal to 0 and x minus 8 equal to 0. So the first solution is negative 2, and the second solution is positive 8, because you're subtracting 2 from both sides and you're adding 8 to both sides.
Okay.
Okay, so let's try another one like that. I'll make it up here. We'll go x squared minus 7 equals, let's go 6x. Yes. Okay. So try this one here on your own. I'll give you like a minute and then I'll work the solution on it if you've got some pencil and paper. I'm just going to start working this out here. So x squared. Oh, I don't know what happened there. I'm going to share it again. Having some technical issues. Okay, so we're going to x squared minus 6x minus 7 equals 0. And then you're trying to find two numbers that multiply to negative 7 but add up to negative 6. So negative 7, the only two possibilities are negative 1 and 7 or 1 and negative 7.
Mm-hmm.
And you can see the second one adds up to negative 6. So it's x plus 1, x minus 7 equals 0. So you said x plus 1 equal to 0. That's x equals negative 1 because you subtract 1 from both sides. X minus 7 equals 0. Add 7 to both sides. X equals 7. Were you able to work that one out on your own, or do you see what was missing if you didn't?
I worked it out on my own. I was
Great.
just a little slow.
That's okay. Do you know if this is a time test that you're taking for?
Oh, it's not.
It's not. Okay, great. Because time often works against most students, and that's never in your favor. Okay. Next question here. This says to solve using the quadratic formula, and that's what we're going to do because we want to get at least one problem where we review that. So the first thing you want to do here is you want to get all terms on one side of the equation. Okay, and it's best to move it left because you want positive x squared. You always want positive x squared if you can. Subtract 4, subtract 4. So on the left side, you've got kind of this conglomeration of terms, x squared. It's really plus 3x minus 4 equals 0. Now, the nice thing about this one is that you could actually factor this, but it says to use quadratic formula, so that's what we're going to do. We're going to use it because it tells us. I'm so sorry, my screen sharing stopped again. Not sure why. Haven't had this many issues in a while. Let me get back to that. It's closed. That's why. Okay. I apologize. Start normally. Start normally. Get this figured out here. Okay. So the quadratic formula is x equals minus b plus or minus the square root b squared minus 4ac all over 2a. I know I'm asking a lot of questions. We talked about calculator, we talked about time, and now I'm going to ask you, do you think you'll get a reference sheet with the exam? These are all things to think about.
Yeah.
I'm going to give you all the formulas, but I may not. They may not when you do this. So,
Yeah.
what is a? What is b? What is c? A is the number in front of x squared, so we know that a equals 1. B is the number in front of x, and it takes on the sign. So here it's positive 3. C is the other number, which is negative 4. So it's just a matter of putting these numbers into the equation to get the answer here. So we're going to bring this equation down, but we're going to substitute in negative 3 plus or minus the square root b squared, so 3 squared minus 4 times 1 times negative 4, close parentheses, all over 2 times 1. And really the hardest part is getting what's in the root simplified. If the b was negative, we would put it in parentheses. Sometimes we use parentheses to show substitution. So like here, c was negative. I put in parentheses just to not miss a sign with that. So I'm just going to come off to the side here. This is 9 minus 4 times negative 4. That becomes negative 16, but then this subtraction makes it positive, plus 16, which equals 25. So everything inside the root here is really 25. So x equals negative 3 plus or minus the square root of 25 all over 2. And you know that that is 5 over 2. So there's really two answers here. Negative 3 plus 5 divided by 2. So I chose the top one. Then negative 3 minus 5 divided by 2. So the top one is positive 2 over 2, which is 1. The bottom one is negative 8 over 2, which is negative 4. Now, most of the time when you use the quadratic formula, do you recall what it's like when you use the quadratic formula? Did this thing inside the root, did it become nice, or did it sometimes become negatives, reducing roots? Do you remember doing some of that last year?
Yeah, just a little bit.
Okay. We can do another example if you would like, or we can move on to a new topic. What would you like to do?
One more example, please.
Okay. So we're going to do, the example here is 2x squared minus 6 equals 3x. Same instruction, says solve by quadratic formula, QF quadratic formula, that's my notation. Again, you want to move everything to one side. So we're going to move the 3x to the left. You're subtracting 3x from both sides. That's 2x squared minus 3x minus 6 equals 0. You have to be able to identify A, B, and C. A is the number in front of x squared. B is the number in front of x, but it takes on the operator. So if it's negative, it becomes -3, or subtraction becomes negative. And then C is whatever is over here. It could be positive or negative. We don't know. Now I'm gonna help here just by grabbing this formula and copying it down for you to see. I would ask you to try doing this on your own. Really what I'm concerned about is, can you get this part done? And I'll just remind you that B is negative, so you want to do -3 squared minus 4 times 2 times -6. Give yourself a minute here and see if you can work through this on your own, please. All right, I'm just going to start working through this a little bit, and you can follow along or look up whenever you're done. See where you're at. It looks like, Julia, that there's no way to go past this point. The square root of 57 is 3 times 19. 19 is a prime number, so it's 3, so there's no further step to take. I'll just point this out. This is like a very specific thing, but some instructors want to see it this way: 3/4 plus square root 57 over 4, comma 3/4 minus square root 57 over 4 as being your two solutions. Both are correct, but this bottom one is probably what is preferred by most instructors when they see you do this.
Okay.
Okay, so we're going to move on to some grouping, factor by grouping questions. You did a lot of factoring in before that. They don't really, algebra, just to be clear, geometry, it's not really used in algebra 2. You could probably go, a lot of students in other schools have gone, they just go algebra 1, 2, algebra 2. A lot of what you did here in algebra doesn't really help algebra 2. So I think you did pretty well in algebra 1. I guess you did pretty well in algebra and geometry as well, but just understand that it's not like you're going to see a lot of shapes and parallel lines and stuff. So this question here, it says factor by grouping. I sometimes call it double factoring because you end up doing it twice. This one's symbolic. You might say, how can I do that? I'm not sure how to do that. You're looking at like the first two terms, and you say, well, what's the same in these two terms? And the answer is there's nothing. And same thing here. There's actually nothing the same, but when you're adding or subtracting, you can reorder. So what I mean by that is 4 plus 5 is the same as 5 plus 4.
Yeah.
So here, if we keep in mind that this is positive, we can say, okay, well, let's rearrange stuff. Like, let's go xy minus 2x. So I grab this first one and this one, minus 2a plus ay. So I grab those two and move those. Now, is there anything common to the first two terms?
The x.
The x. So we factor x out. Y minus 2. As a reminder, if you were to distribute in the x, you should get back to the previous line. It would be xy minus 2x, which is what's up here. Now, what's common in the next one here?
The a.
The a. So I'm gonna put an a out here. And this is a little awkward, but it's gonna be minus 2 plus y. Okay. A was positive, by the way. I should have wrote that down there. Are these the same that are inside parentheses?
Yes.
They are. The one on the right can actually be written as y minus 2. You're just swapping the positions of them. I've got a lot of errors going on, but you're just swapping positions. So yeah, we have the exact same thing here. Okay. Now this is where the double factoring comes in. We've already done it once. This is our factoring here once. What is common to both of these that I've got kind of more of a squared off underline here? They both have a y minus 2 in them.
Mm-hmm.
So that factors out. The first one has an x, the second one has an a. Was that, and I'll draw some more arrows, maybe they're confusing, but we'll try that.
Yeah.
Okay. How was that for you? Is it do you remember doing that? Is it, hopefully it's not the first time you've seen it.
Yeah, I remember.
Great.
Doing that.
This should all be review. And that's how you want to feel when you go into this test. You want to feel like, okay, I've seen this before. I just got to figure out how to do it. There shouldn't be anything new. I hope that would be the best case scenario. Okay. 2amn minus 6n minus 3m plus am squared. So this is it would have the same instructions. I'm not copying those. It would say factor by grouping. It could just say factor. Whenever you see 4 terms like this, that you know it's almost always grouping. Okay, so let's look at the first 2 again, and that's what we did in this previous problem. But the previous problem didn't have anything the same in the first 2 terms, but here we definitely have the n is the same. And what else? There is something else that's common to both of these.
The 6 and the 2.
Right. So 2 goes into both. So 2n, and then what's left over? Well, there's an am. I just grab those, minus 3. And this is a better example of like if you distribute this back in, you get back to the previous line.
Mm-hmm.
Okay. Now let's look at the next one. What is common to both here? And this,
The m.
The m. So I'm going to put an m out here. Minus 3 plus what goes here in this position?
Another m.
That gets you to m squared. What about the a?
Am.
Am, good. Okay. This is positive. Okay. Now my question to you again is what's inside? Are these the same?
Yes.
They are. They're written differently. So this one we're going to add is am minus 3. M here. 2n. Now this is where the double factoring comes in because you got to do it again, or factoring twice. What is common to both of these? What do they both contain?
Parentheses.
Yeah, the thing in parentheses, am minus 3, and then you just bring down the other stuff, 2n plus m. All right, we're going to switch topics slightly. Just as a reminder, I will send you a PDF copy of the notes and the screen recording. Do that right away. Towards the end of the semester, I do get a little busy, but definitely can get this to you right away so you have it for review.
Right,
We're going to simplify or rationalize is really what we're doing here. Some expressions. So let's say I gave you 6 divided by the square root of 2. This is like the third commandment of math is you don't leave roots in the bottom of an expression like this. So do you recall how to eliminate this root in the bottom?
Kind of. I've forgotten just a little bit.
Yep. So the way you do it is you multiply the top and bottom by the same thing, but it has to get rid of the root. So why does this work? Why is it square root of 2 over 2? Well, when you multiply square root of 2 by the square root of 2, it becomes the square root of 4. And you know that value. What is the square root of 4?
2.
2. Okay. So up top, this does not have a root, this 6. This does. They just squeeze together. If you could see my hands, you'd see me pushing them together. 6 square root 2, 6 square root 2. Okay. Now this 2 can divide the 6, but not the root 2. It's hanging on the outside. Don't worry, we're going to do another example here. This becomes 3 square root 2.
Okay.
So let's try another one. 9 over square root 3. This is exactly the same as the top one, same set of steps, same reduction here at the end. Give this a try on your own, please.
Um, 3 square root 3.
I'm so sorry, Julia. I don't think you heard me for a few minutes there.
Yeah, it's okay.
Okay. So boy, the technology's not working for me today. Not your fault though. Give this one a try, please. See if you can work it out. It's very much like the one I just did. It looks exactly the same. And then I'll work it out here, but let's give yourself a minute to see if you can work this out. I'm going to start working this one out just so you can see the steps for it. You're going to distribute to both of these. So it's 3 square root 9 plus square root 9 over square root 9. So this, it's slightly, I guess it is slightly different. The square root of 9 is 3, so it's 3 times 3 plus the square root of 9 is 3 over 3. Lots of 3's going on here. This actually does reduce to a nice number. 3 times 3 is 9. 9 plus 3 over 3. 12 over 3 is 4. Let me know when you're caught up to me here.
Okay.
All good? Ready to go on to a new problem?
Yes.
Okay, so let's look at some lines stuff. There's 3 forms of a line, so I'll give you just a little review. Do you remember any of the 3 forms of a line that you might be given or asked for, either in words or equations?
Not really.
Okay, so here's one, and you're gonna say, I remember seeing that. Do you remember what it's called? It's like
Slope-intercept.
slope-intercept, yeah. It's like watching Wheel of Fortune. You get to see the things come on. How about this one? Y minus y1 equals slope x minus x1. Do you remember that?
Point line.
Point slope
Point
form.
slope form.
Okay. And then the last one is standard form. So maybe you're given these, probably not, but you very well could be given them. So let's say I gave you these points. I said, here's a point. And here's another point. 6 comma 7. Could you find the slope between these 2 points? Do you remember that formula?
It's like y2 minus y1 over x2 minus x1.
Excellent. Okay. So give that a try here. See if you can find the slope between these 2 points.
Um, 14 over 3.
So it's 7 minus a minus 6. Is that what you got? 7
Yes.
minus. Okay, so that's 13.
Oh, 13.
And then 6 minus 3 is 3. So just double check what you got there. See what you got written. 13 over 3. This does not reduce, so it's as is. Let's do one more. So let me give you the points: 1 comma negative 3 and 4 comma 9. Give that a try, please, with your slope form. Let me scroll up just a little bit so you can see it. There it is.
Um, 4 over 1.
Yes. So 9 minus a minus 3 over 4 minus 1, 12 over 3, which is 4 over 1. So that means it's 4 up and then to the right. So it's rise over run, or if it's positive, it goes up. If it's negative, it goes down. Okay, so let's try this. I'm going to grab an equation here and ask you for the slope of this equation, slope of this line. So let me snip it in. Here it is. What is the slope of this line? And if you have no idea, just say so.
Okay, let's see. Y. The slope is 2/3.
2/3. So the slope is the number in front of x, which is 2/3. The b is the y-intercept. It's the other number. What is that?
3.
3. Okay. So let's say I wanted a parallel line. Parallel lines have the same slope. So what would the slope be if it's parallel to this one?
3/2.
Parallel, they have to have exactly the same slope. So no changes, exactly as is. What would that be?
2/3.
2/3. Okay. Now, if I give you the same b value, they're the same line. Do you see that? They would be the same slope, same b value. So it can't be 3. Give me another number besides 3.
-3.
Great. Good choice. So if they have the same slope, they have to have different b values to be parallel. Okay, but this is what makes them parallel. Okay, now let's say I told you that the slope was -5/4, and we wanted the perpendicular slope. And that's what I think you were going for. So perpendicular, you have to do 2 things. You have to flip and negate.
Okay.
So when you flip the fraction, you get this step, you get 4 over -5. When you negate it, what happens?
It becomes positive.
Positive. Okay. So let's say the slope is -2/3. What is the perpendicular slope?
3/2.
3/2. Excellent. So let's go back to the full question here. Kind of had to build into it, but I'm gonna grab the full question now because we finally have enough on our side to do it. Okay. All right, let me snip here. Find the equation of the line through this point that is parallel to this line, this equation here. So we've got to find a new equation, but it's got to be parallel. Parallel lines have the same slope. So what is the slope of that line?
2/3.
2/3. And I'll scroll up here. What are the 3 forms of the equation of the line? Well, there's slope intercept, point slope, and standard form. So we're going to go through all 3. We're going to start with point slope. Okay, so the point slope form is y minus y1 equals slope x minus x1. You have your slope. This is x1 and this is y1 because they're given. Those points are given. So it's y minus -6 equals 2/3 x minus 3. And this is in point slope form. And you're done. There's no more. There's nothing else to do here. This is your. Are you driving yet?
A little bit, yeah.
A little bit. Okay, so this is your stop sign. Like you're done. Okay. Now you can very easily move from point slope to slope intercept, which it could reasonably ask you to do, and you do this by solving for y.
Okay.
So to do that, we have to distribute this 2/3. We have to combine the signs there and then move this, whatever this is, over to the right. We don't have to do that all in one step though. So it's y plus 6 equals 2/3 x minus, and I'll just write it this way. There's no reason to do too much in one step. Minus 2/3 times -3. -3 is really -3/1. So you can see that the 3's cancel, or you can multiply 2 times -3 to get -6/3. However you like. The result is that this becomes 2/3 x plus 2. Do you see that?
Yes.
Okay. Now we're not quite there because we still have this 6 on the left side of the equation. So we're going to subtract 6 from both sides of the equation. Y equals 2/3 x minus 4. So why is this in slope-intercept form? Because it looks like y equals mx plus b, or as I said up here, solve for y. So you have to know, hey, I got to solve for y.
Okay.
The very last form is going to standard form. So we're going to go to standard form. And standard form is ax plus by equals c. There are no fractions. Do you see any fractions here?
2/3.
Yes. 2/3. So that's bad. How do we get rid of fractions? You have to multiply by the denominator if you only have one. So in this case, we're going to multiply both sides of the equation by 3. When you multiply both sides, again, you want to distribute to both. It's not a choice. You both here. So I know in some questions you can, some things we do in math, you can just do it to one thing, but here to both. So it's 3y equals 2x, 2 times 3 is 6, 6 divided by 3 is 2, minus 12. Okay, and the reason we, again, we'll just reiterate, because a lot of students don't do this, is they forget to multiply this in, they get, an answer that looks right, but it's wrong, so on. So we're trying to get into this form, ax plus by equals c. The most common thing to do is to move the 2x over to the left, and you think, oh, I'm done. Negative 2x plus 3y equals negative 12. But a has to be positive. A is negative. So how can you switch the sign of this? You can't just change it to positive. You have to multiply everything by negative 1. So that one, and that one. So it becomes 2x minus 3y equals 12, and everyone's happy.
Okay.
Okay. It'd be normal if you haven't done much math in a while to feel a little bit, we're getting kind of like a little tired maybe because it's a lot to take on. Let's do, trying to figure out what to do next. Let's just switch it up. This is good for the brain to kind of do some different types of problems. I skipped some of the statistics and probability questions. They're not that complicated, but they're very different than what we've done so far. So let's look at this question. A single 6-sided die is rolled 3 times. So there's the assumption that you know that a die has 6 sides. It's labeled 1 through 6. Okay.
Okay.
Okay. So let's not ask about all 3. Let's the probability that you get a 6 the first time.
1/6.
1/6, right? And how about the second time?
1/6.
1/6. So if you're unsure, you're trying to. Sometimes we try to think of a way like why, like it can't be the same, but it is. Like every time you roll a die, it's the same each time.
Yeah.
So the third time, what's the probability of rolling a 6?
1/6.
So when it asks all 3 times, it's the same as saying like, and, meaning like they all have to be true. First and second and third. And usually means multiplication here.
Mm-hmm.
All right. So if you have if you had to do this by hand, you could do it. It would be 1 out of 216. Okay. So let's do a related question. I'm gonna just type this up. This one, it'll be real quick here. A coin is flipped. What is the probability of heads all 4 times? So you're flipping it 4 times. Hopefully that's large enough to see. Let me see if I can increase the size a little bit here. There we go. Okay, so it's no different than the previous problem, because you just have to figure out what's the probability of getting ahead the first time.
1/2.
1/2. And how about the second time?
1/2.
Okay, how about the third time?
1/2.
And the fourth time, I'll fill it in, it's 1/2. So what does that become? 1 out of
16.
16. Very good. Okay, let's look at maybe the only, on this particular one, it's a it's a volume problem. It's probably the only thing from geometry that that they want here. So
Okay.
let's see here. So they want the volume of this solid. So this solid, it's a triangular prism. I'm trying to think of something. It's a tent. I guess that's a tent shape. And then if you had a cat's, or I guess maybe dogs do this, they have like a sleeve and they run through it. Maybe you can envision that's there. I don't really know what this is, but it's two shapes. It's this triangular prism. Okay, and then there's a cylinder. So do you recall the formula for either of these?
I don't.
So the volume is equal to the area of the base. This is most generally times the height. So for example, a cylinder, the volume of a cylinder, what is the base shape here?
A triangle. Oh, a circle.
Circle. And the area of a circle is pi r squared times the height. So do we have that? Do we have the radius? We do. See how that's the radius 2? And this is the height. The height is really like the sometimes the better word, it's the extended part, extended, or they sometimes say protruded in computer design classes, but it's the length or length. That would be okay as well. Any of those words mean the same thing in this context.
Okay.
So here it's pi 2 squared times 10. The radius is 2, the length is 10. I'll put those in here. Now you could grab a calculator, but the answer is in terms of pi. So 2 squared is 4, 4 times 2 is 8, 8 pi. Okay. So this triangular prism, what is the, I'm going to call it a tent because I don't know what else. It is a triangular prism, but it's better to write. We'll just write it this way. What is the front face? It's a triangle. It's in the name. The area of a triangle is 1/2 base times height. Now we already used the word base up here. Base means this front edge. Do we have this front edge that I'm underlining?
Yes.
8.
It's
8. 1/2 8. And then the height is actually here. This 4 square root 3. And then the part that I'm missing here is there's a length that it's been extended. That this L is how much it's been extended again, which is 10.
Okay.
So the most important thing, because you multiplying these numbers, you know how to do, or it'll become clear when we do it. Is there anything about how we put the numbers into the equation that is you're uncertain about, or like how did I know that it was a height, or the base? Is there anything in there that's you'd like me to say again or use different words for?
No, it's okay.
Okay. So then the last step here is to simplify this thing on the bottom. 1/2 of 8 is 4. 4 times 10 is 40. So see how we combine those. And then 40 times 4 is 160, square root of 3. So the volume of the thing, I don't know what to call it, it's the larger section subtracting out the smaller section.
Okay.
So let's try one similar to this. Let's go it's a stick of butter, And let's go 4, 5, 10. And let's say you cut out something in here. It's got a radius of 1. Okay, so it's slightly different. I'd like you to do the same thing. The volume of the butter, called a butter stick, is length times width times height. Length times width times height. And then the volume of the cylinder is pi r squared. And then I'm going to use L. L, though, is this direction. In the previous problem, you might have made L like 4. If that's not clear, I can cover it again. But I'd like you to try working through this on your own here. I'll give you 60 seconds to give it a shot, please. Okay, I'm going to just start putting some of the numbers in. You got 4 times 5 times 10. That's 200.
Mm-hmm.
And then pi, your radius is 1 squared times 10. So that's 10 pi. So your volume of your thing, because I don't have a word for it, is the bigger one, which you may not be able to tell by the numbers, but in this case, you know the butter is bigger than the tube.
Mm-hmm.
10 pi.
Okay, that's what I got too.
Great. All right, let's look at another question here. This one is at the end of this particular test. It's not meant to be difficult, but like sometimes when you do questions just in order, you might get to think, oh my gosh, this is so difficult. You're supposed to solve this. The thing that might be misleading is, oh, there's fractions, but you can actually clear the fractions first. And we talked about in an earlier problem just multiplying by the bottom number. Well, that doesn't work here. You have to find the least common multiple of 2 and 3, and that
Mm-hmm.
is 6. And this is where it gets a little confusing because it's like, wait, I got to multiply everything by 6. Well, yes, but let's just look at these one at a time. So 6 times 5x over 2. You could multiply in, that's 30x over 2. What does that become? 30x over 2.
15x.
15x. Yeah. Now this is a little bit deceptive here. This next one, it's really minus 6 parentheses x minus 2 over 3. I know in the previous one we multiplied in, you actually want to divide first. But if you don't like that, we can multiply in first. What would you prefer here?
It doesn't matter.
Okay. So like I see it as division first. So it's minus 2, 6 divided by 3 is 2, parentheses x minus 2 equals, and that's why you show each of these lines so you don't forget, 42. 6 times 7 is 42. So now you can distribute this 2 in, but it's really negative 2. And that's another little wrinkle here. Like if you don't remember this negative 2, you'll miss a sign. So it's minus 2x, but negative 2 times negative 2 is positive 4 equals 42. These two make 13x. If you subtract 4 from both sides, you get 38. Divide by 13, divide by 13, x equals 38 over 13. This is not nice, but that's okay. You shouldn't expect it to be nice all the time.
Yeah.
Okay, let's do one more. Let's do 3x over 2 minus x minus 3 over 3 equals 5. So very similar to the previous one. you're going to multiply everything by 6 because 6 is the least common multiple between 2 and 3 is 6. So get a start on that. I'm just going to mute you here and then we'll finish off this question shortly together.
Okay.
All right, so I'm going to just start putting down some numbers here. So this is 9x minus 2 parentheses x minus 3 equals 30. I did skip a little bit here. Let me know if any of that's unclear or if you got something different I can explain further.
That's what I got.
Great. So I'm going to distribute this -2 into both. 9x minus 2x plus 6 equals 30. 9x minus 2x is 7x plus 6 equals 30. Subtract 6 from both sides. 7x equals 24. X equals 24 over 7. All right, well, that takes us to the end of the lesson. We did get the full time in. Thanks for being patient with my technical difficulties.
Yeah, of course, no problem.
I'll send you. Yeah, you're welcome. I'll send you the notes on the screen recording shortly. If there's any videos that you think would help you, you can just text me directly. I'm doing some more videos on the website. So if there's something you want to see, or if you have questions, I can definitely make them to help you out. But thanks again for scheduling, and I'll see you next time.
Thank you for helping me.
You're welcome. Bye now.
Bye.